All right, so we are going to begin factoring with basically just dots and trinomials. Okay, dots, difference of two squares. For example, that would be something like x squared minus 4. You have x squared that's a perfect square, 4 that's a perfect square. It's a difference that's important to make sure you're subtracting them. And when you have that, you can break that into two sets of parentheses that both start with x. Okay, one's a plus, one's a minus, and they end with 2 because that's the square root of 4. Be super careful because if you ever have anyone that says like 9 minus x squared, doing something like x plus 3x minus 3 is actually incorrect. The fact that 9 comes first, the 3 would have to come first. One's a plus, one's a minus, the square root of x squared is x, and that would be the correct factoring version for dots. So as I take a look at number 1, I look to see if there's a GCF. Unfortunately, there are no GCFs, nothing that divides evenly into everything. So then I see that 4x squared is a perfect square. Just so you're aware, powers of x that are even are perfect squares. 49 is a perfect square. There's a minus in between them, so I can use dots. So I'm going to break this into two sets of parentheses. Okay, when I take the square root of 4x squared, I'm taking the square root of 4, which comes out to be 2, and the square root of x squared, which comes out to be x. So 2x starts each of these parentheses, one's a plus, one's a minus, and the square root of 49 comes out to be 7, and that is my factored version for that expression. By the way, it doesn't matter if you had put the plus first or second, as long as one's a plus and one's a minus. Okay, so that's when you have two terms. It's either going to be dots or GCF. When you get into three terms, it's going to either be a trinomial, a tricky trinomial, or it's just going to be a GCF problem. So I first look for a GCF. I don't see one. I do see I have three terms. That's why it's a trinomial. And thankfully, it's not a tricky trinomial because it's just a plain old x squared in the front. So for this, I'm going to use something called the AM method. You're going to do two sets of parentheses. They're both going to start with x because the square root of x squared is x. And then you're going to use the a and m to figure out what values add up to -4 and multiply to my last term. That's what AM stands for. So you know that add has to be the middle term, multiply has to be the last term. If you ever get stuck, look at the factors of the last term. Thankfully, there are only 2, so you fill in the 1 and 3. The fact that they're multiplying to a positive, that means they're going to have the same sign, and the sign that they're both going to have is going to be the sign that's in the middle. So it's going to be x minus 1, x minus 3. Then I go into question number 3. Again, I see a trinomial. There's no GCF, and it's not a tricky trinomial. There's nothing in front of x squared, so that's why I'm going to call this an AM trinomial. So I'm going to do two sets of parentheses. They're both going to start with x. Okay, I'm going to take the factors of 56. So as I go through, I have 1 and 56. I'm sure I have 2 and something. Eventually, I'll find out that I have 7 and 8 that are factors of 56. Just so you're aware, if you ever get stuck, if you're like not great with factors, go to y equals, take the number you want the factors of and hit divided by x, and take a look at the table. As long as you're starting at 0, excuse me, all of the whole number pairs are factors of that number. So 2 and 28, 4 and 14. Eventually, I scroll down. I see 7 and 8. Once the left-hand side gets bigger than the right-hand side, there are no more factors that are pairs. So I'm going to use 7 and 8. Okay, so I fill that in. The fact that they're multiplying to a negative, that means that they're going to have different signs. Okay, and the fact that they have different signs, the sign in the middle is going to go with the larger number. So the fact the sign in the middle is negative means the 8 is negative because 8 is bigger, and 7 is a positive. Now, when you look at question number 4, okay, so again, you see three terms. There's no coefficient in the front, so it's not a tricky trinomial. I know you're thrown off a little by the fact that it starts with x to the 4th, but it actually is still just a trinomial. So you're still actually going to start by just doing AM method. The only major difference is when you do two sets of parentheses, notice how before we started with x and x because those multiply to be x squared. Now I'm going to start with x squared and x squared to make sure that I can multiply back to being x to the 4th as my first term. Okay, so I'm going to do AM method like we were just doing in the previous trinomials. What numbers multiply to be 12 and add up to be 1? 1 and 12, 2 and 6, 3 and 4. It's going to obviously have to be 3 and 4 that adds or subtracts to be 1. So I fill in the 3 and the 4. The fact that this is a negative means that they're different signs. And if they're different signs, the sign in the middle goes with the larger number. So 4 is bigger than 3, so 4 gets the negative, and 3 gets the positive. Now you'll notice in this case, do you see how I have a dots problem left over in that parentheses? You should always be trying to factor completely. So I have x squared plus 3 will come down, that will have to stay part of my expression, but x squared minus 4 will become x plus 2, x minus 2 when I factor that using dots. Okay, so now we're getting into factor by grouping and tricky trinomials. Okay, so tricky trinomials, the way I do them relies a lot on factor by grouping, so that's why I'm going to start out with that. I think it's one of those things that just takes a little bit of practice, but you'll get there. So starting with factor by grouping. Factor by grouping you'll know to do because you have 4 terms in your problem. It's not 2 terms where you're doing dots or GCF. It's not 3 terms where it's just a trinomial. It has 4 terms. So you're going to chop it in half, and you're going to GCF each half of your expression. So as I GCF the first half, x squared can come out, and I'm left over with x plus 1. Now whatever sign comes after the split bar, that's going to be the sign of your coefficient, your GCF in the second half. So negative 3x minus 3, I can factor out a negative 3. As I divide negative 3 into each of those terms, I'm left over with x plus 1. See how these parentheses come out to be the same? That's a crucial part of doing factor by grouping, because now what's going to happen is you're now going to GCF this parentheses out to the front. So I'm going to pull out an x plus 1 to the front of my expression, and in parentheses what will be left over is whatever my GCFs were, x squared minus 3. So again, I'm pulling x plus 1 to the front, and I'm taking whatever's left over and putting it in its own parentheses, and that's it. That's my factored version of that polynomial. So I'm going to repeat the same thing for number 2. I'm going to chop it in half. I'm going to GCF the first half of the expression, so I'll be left with 5m plus 7. From the second half, notice that there's a negative after the split bar, so you'll have to have a negative GCF. And then I'm going to pull out a 2, so that would leave me with 5n plus 7. Again, when you're doing grouping, you need to end up with the same parentheses in each half of the expression. Now you're going to factor out this common parentheses, 5m plus 7, pull that to the front, and then put whatever's left over in its own parentheses, and now you factored that polynomial. So the idea with factor by grouping is you have to have 4 terms. We're going to end up using factor by grouping to factor these tricky trinomials. Why are these called tricky? Well, they are trinomials, 3 terms. Unfortunately, you have a number in front of the x squared or the n squared that cannot be GCF'd out. So what you're going to do to start out is you're going to find a way to keep the first term, keep the last term, and split the middle term so that you have 4 terms all together. The thing is, you can't just split the middle term however you feel like. It can't just be like, 1n and 11 and 10n, or 9 and 2. It has to fit a specific AM type problem, just like when you're doing regular trinomials. So you're going to multiply the first and last numbers together. Those multiply to be positive 24. That's your M. Your A goes in the middle. You're always going to keep your first term, and you're going to keep your last term, but you're going to split your middle term. Okay, so I'm going to be doing an AM problem just like we were doing with our regular trinomials. What multiplies to 24 and adds up to be 11? So 1 and 24, 2 and 12, 3 and 8. Okay, so 3 and 8 is going to multiply to 24 and add up to be 11. They're multiplying to a positive 24, so they're the same sign, and they match the sign of what's in the middle. So positive 3, positive 8. Only remember, I said you're splitting your middle term, so I have to have this as 3n and 8n, so they add back up to 11n. Now that I have it as 4 terms, I'm going to go back and do it as a factor by grouping problem. So I'm going to chop it in half, GCF the first half. Okay, there's a plus after the split bar, so your GCF in the second half is positive. I can pull a 2 out of the terms on the second side. As I divide 2 into each of those terms, I end up with 4n plus 3. Again, remember, as you do grouping, you should be getting the same parentheses twice. Now I'm going to factor out this parentheses, 4n plus 3, and whatever's left over, n plus 2, goes in its own parentheses, and now I factored that tricky trinomial. If you want a quick way of checking yourself, check that the first terms multiply to the first term, and the last terms multiply to the last term. 4n times n is 4n squared, 3 times 2 is 6. That's usually a pretty good indicator that you factored it correctly. Okay, so we try again with number 4. I have only 3 terms. That's why it's not automatically grouping, but I notice that there's a number in front of x squared that I can't GCF out. That's why it's a tricky trinomial. So I'm going to multiply 4 and 5 together, so that comes out to be 20. That's my m, and negative 21 is my a. I'm always going to keep my first term and keep my last term, and I'm going to split my middle term using this combination of am. So what multiplies to 20, oopsies, what multiplies to 20 that adds up to be 21? 1 and 20, 2 and 10, 4 and 5, you'll see that it's 1 and 20. They're multiplying to be a positive 20, so they have the same sign, and their signs then have to match whatever was the middle sign, just like when you did a regular trinomial. So this is negative 1 and negative 20, only it's negative 1x and negative 20x. So now that I have 4 terms, now I'm going to use my factor by grouping to be able to finish factoring this. Chop it down the middle, GCF the first half. When I pull out an x, I'll be left with 4x minus 1. I'll have a negative GCF in the second half because of the negative after the split bar. I can pull a 5 out of each of those terms on the right, and what am I left with? 4x minus 1. Be careful, you're doing 5 divided by negative 5. That's where negative 1 comes from. Remember, you're supposed to have the same parentheses twice. Now you're going to factor out that common parentheses. 4x minus 1 gets pulled to the front. X minus 5 is left over in parentheses, and now you factored your tricky trinomials. I'm telling you, if you practice it 2 or 3 times, you will get the hang of it. Okay, factoring completely means you're pretty much doing a combination of all of our factoring methods put together. Generally, one of the first things you want to always look for is to GCF something. So GCF, and again, the fact that we're factoring completely, you're most likely going to follow that up with dots or trinomial factoring or, tricky trinomial factoring or whatever it happens to be. So as you take a look at the first one, 45 and 80, you'll notice that 45 and 80 both are divisible by 5, so I'll pull my GCF of 5 out, and I'll be left with 9m squared minus 16. So again, the fact that we're factoring completely means we most likely are going to have to use more than one method. You look at what's in parentheses and see if you can factor it further. Remember to keep that 5 out front. The goal is to create an equivalent expression, so if I remultiply everything back together, I should get back to my original expression. So I do 2 sets of parentheses. The square root of 9m squared would be 3m. One's a plus, one's a minus. The square root of 16 is 4. And that is my factored version completely for that expression. And again, if I wanted to check myself, I'd remultiply all this together, distribute the 5 back in, and I should end back up with the original problem. So as I take a look at question number 2, I see I have 2k to the 4th minus 34k cubed plus 144k squared. You'll notice that all of these are even numbers, and I can pull a k squared out of each of those. If you have 3 different variables, it's usually the lowest power of them that's going to be the biggest thing that can go into that. So I'll pull a 2k squared out of each of those terms. As I do that, I'll be left with k squared minus 17k. Just checking so I don't make a mistake. 144 divided by 2 is plus 72. Okay, notice that what's left over is now an AM trinomial. Okay, so that 2k squared stays out front. And now I'm going to do 2 sets of parentheses where I find out what adds to negative 17, what multiplies to 72. The fact that it's just a plain old k squared, that's why I'm able to use regular AM method of factoring and not tricky trinomial stuff. So I'll put a k in the front of each of these parentheses. If you ever have trouble with the factors of 72, remember what I said before. Take 72 divided by x. You're looking for a combination that adds or subtracts to be 17, so 8 and 9 will be your combination. So 8 and 9 get filled in. The fact that they're multiplying to a positive means they're the same sign, and that sign matches the middle term of that expression. So minus 8, minus 9. Okay. On to question number 3. So once again, you're starting with GCF factoring, 4x to the 4th, 36x squared, negative 40. Unfortunately, I can't pull an x out of all of these, but everything is divisible by 4. So I'll pull that 4 out, and then I get x to the 4th minus 9x squared minus 10. So now I'm going to make 2 sets of parentheses, and I'm going to use AM method of factoring to finish factoring what is left inside that parentheses. Keep my GCF of 4 out front. Okay, even though I know it starts with an x to the fourth, it's still a trinomial where the first coefficient is 1. So that's why I'm able to use regular AM factoring. So I take the square root of x to the fourth, x squared. That's the one major difference when you're factoring something like this, is that you have to start with x squared in your parentheses. You want to find two things that multiply to be 10 and add up to be 9. That would be 10 and 1. Okay, because of the fact they're multiplying to be a negative, they are opposite signs. The larger sign, the larger number, goes with the sign in the middle, so negative 10 and positive 1. And then obviously you're always looking to see, can you factor it further? In this case, you cannot, so that is your final factored version. And then finally, last but not least, with question number 4. So you see, okay, I have 3x cubed, 22x squared, 45. Now I see that 3 goes into 45. Does 3 go into 22? Unfortunately, when I do 22 divided by 3, it doesn't go in evenly. So the only GCF I can do here is to pull out the x. So I'll be left with 3x squared plus 22x minus 45, which means that what's left inside that parentheses is a tricky trinomial. So I'm going to write that on the right-hand side and do that factoring off to the side and then put the final answer back inside here. So what you're trying to do here is to factor this with tricky trinomials is turn it into a factor by grouping problem. Keep the first term the same, keep the last term the same, and split the middle term. But again, you can't just randomly split the little middle term however you want. You have to figure out what AM combination, let's see, 45 times 3 is negative 135. What AM combination will work to split this up so that it adds up to be 22 and multiplies to 135. Once again, pretty large number. I don't even know the factors of 135 off the top of my head. So 135 divided by x, take a look at the table. Okay, so as I scroll through here, I'm looking for two things that are going to add or subtract to be 22. I can see right here 5 and 27. Okay, so I'm going to have 27 and 5x. They're multiplying to be opposite signs. The sign of the larger one gets the sign in the middle, so the 27 gets the plus, and the 5 gets the minus. Okay, now that I have 4 terms, now I'm going to chop it in half, GCF the first half. Okay, then the negative will be part of the GCF of the second half, and I can see 5 can be pulled out of that, so I'll have x plus 9 left over. Once again, I'm supposed to have the same parentheses in each half of this expression. Now I'm going to pull that parentheses to the front. X plus 9 gets pulled to the front, and then 3x minus 5 will be left over. Now remember, you're not totally finished. You're doing that to factor what was left in that parentheses. Your final answer has to have the x back in front. So x times x plus 9 times 3x minus 5, that's your final factored version of that expression.